All right, CNT125, we're working on Chapter 11. We just got done talking access lists. We are going to do a number of access lists in our Chapter 11, Chapter 12 labs as we move on this semester to filter out certain traffics. The book mentions a policy mapping or class mapping. This you run into on some firewalls, some of our like ASAs that we had and so forth. You started doing some of this configuration. So this is something you might run into, so it's worthwhile to be at least familiar with it. Once you define an access list, you then create a class map. And this then can be used to filter traffic at almost like a little bit of a higher level on the device, whether it be a router, firewall, etc. And then this can do the filtering for you instead of just the granular access list. So just be aware that that might be configuration that an access or a firewall or something is using. I'm going to remind you what we did in Chapter 10. We did a little bit of port security with the switches. We shut down unused ports. That's always a worthwhile thing to do. We also did some port security where we made sure that not more than one MAC address can show up on a port. This is another level of security that can be done on your switch. So I put this here as a reminder of what we did in our Chapter 10 lab. Some additional switch security. They talk about router advertisement guard. With router advertisements, remember router advertisements happen with certain protocols saying, hey, here I am. Here I am as a gateway. There's no way to verify that they're legitimate unless you do some configuration. You can have malicious router advertisements should be used to reconfigure networks and point them in the wrong direction and create basically a denial of service. Your router guard feature filters these messages to make sure that only they come from a specific interface on the switch. So I think they give you an example here. Yes, legitimate traffic, it's only going to come from, maybe the uplink port here. It's only going to come from the uplink port here. These would be the only legitimate ones. Ones coming in from a user port, it would say no. That cannot be legitimate. It's coming from some host acting like a router. So that can be configured in the switch to prevent those types of misdirection. That's basically what to think of it, misdirection. DHCP snooping. A rogue DHCP server could have a client computer gen up a virtual machine and have it running like Linux and have it turn into a DHCP server. That could be used to send out false DHCP messages so they're pointing to some other entity. Okay, so DHCP snooping can be configured on the switch to indicate this is a trusted DHCP server, not a false DHCP server. So again, you can configure on the switch saying, hey, only trusted DHCP offers and so forth should be coming this direction, not this direction. Anything coming from these like user ports would not be trusted DHCP offers, if you will. That can be configured on the switch. Dynamic ARP inspection can be configured as well. This is to prevent ARP spoofing attacks. Remember, ARP is your MAC to IP address mapping. So with this, the switch compares the incoming message with the DHCP snooping, determine whether the message source IP address is appropriately matched with its MAC address. So it's not somebody trying to snoop or somebody trying to spoof their way in. Again, these typically work together. Your dynamic ARP inspection and your DHCP snooping typically work together to prevent these untrusted entities, untrusted communications in your network. Proxy servers. Proxy servers can act as an intermediary between your internal and external traffic. It's typically going to be a server that we send the request to, and the server forwards it on our behalf, in proxy, if you will. This is going to manage your security at your application layer now. Some of you might have used these when you were think about high school. Your traffic coming from the users in the network went to a proxy server. It filtered the traffic and then handed that request out and brought the information to you. That was acting in your behalf to filter and make sure the stuff you were searching was appropriate and the traffic coming back was appropriate, if you will. So this can be sitting right here in the middle, that all the traffic from inside hits this and it forwards it on. Almost acts like a little shield to protect the users and the workstations in the network. Thinking back, NAT at layer 3, IP address translation, proxy server layer 7, that's your relay service. And again, this is shielding the clients from the outside. Reverse proxy. This is going to provide service to the internet clients from servers on its own network. Again, this can be used when you have multiple web servers accessed through a single public IP address. So as the request comes back, this can then forward it to the correct server. Firewalls. We're going to work with firewalls a little bit in this lab with our Chapter 11 lab. So firewall is a specialized device, computer installed with specialized software that's going to filter and block traffic between networks. A lot of times it is hardware and software implementation. And this acts almost like a bouncer at a door checking IDs. I think that's the example the book uses for us. It's typically between two interconnected private networks, or between a private and public network like we would have at the edge of our edge of our LAN and edge of our branch network, if you will. So this would be our network, and we typically have the firewall sitting there connecting out to public or the link to another branch. We can have a network-based firewall or host-based firewall. The network-based firewall protects the entire network. It's going to sit at the edge of the network. It's usually going to be an appliance kind of like Cisco ASA or Fortinet FortiGate. This is the kind we have in our library that we'll be using. Okay, and just right here, it's typically going to sit just like that. Here's a picture of the one we have in our lab room that you end up using. Here's one that we used in the lab room for a number of years prior to that FortiGate. And it's going to sit right there to protect the whole network. A host-based firewall is an application running on a host machine. It's going to protect just that host. Something like a Windows Defender firewall. That's an additional layer of protection. It's going to protect that host if something happens to move through the network or move through a piece of equipment. That's an additional step. And that would be your Windows firewall that you have turned on, filtering certain types of traffic. And even have rules that we can write in there to filter certain types of traffic. And we're actually going to do that in the lab as well. We'll open up our firewall, make sure it's on, and then we'll add a rule in here to block certain type of traffic. And again, it's out here protecting that node. So I might have one here protecting the whole network, and then I might have some level of firewall on these nodes to protect them as well. Additional layer, additional layer. We can have a packet filtering firewall. This is the simplest one. It's going to examine the header of every entering packet, refer that to the access list for filtering rules, and block or permit. This is very common in your router you have in your house. So these can block traffic entering or exiting a LAN. And I think this is the picture they had in the book for you. And I put a couple bubbles in here to kind of give you an example of what could be done. I can be having a rule on the outside out here, on the outside interface, and I would write it for inbound, so it's going to deny telnet traffic from trying to come into my network, among many other things. I might have many other things in there. But to give you one example, I'm going to deny telnet traffic from trying to come into my network. In addition, I might have a second rule here on the inside preventing the users in this network from trying to FTP data outside. So I might have a rule here that's going to deny FTP traffic from trying to leave the private network and go outside. So users cannot send files out and compromise the business. So on this firewall, I can have rules on the outside limiting traffic coming in. I can have rules on the inside limiting traffic trying to leave. And that's what they're trying to tell you here. It can be filtering traffic inbound or outbound, depending on what you need it to do. And things like this are going to be very common. Having rules filtering traffic coming from the outside in, what it's allowed to do, and traffic from the inside leaving, what is it allowed to do. Firewall default configuration, a lot of them are going to default to either permitting everything or denying everything. It kind of depends on the manufacturer. Sometimes it literally is going to deny everything and you have to permit it all, or vice versa, it's going to permit it all and you have to deny what you want. And that's where the network admin needs to come in and configure and start configuring what is permitted, what's denied. We'll do a little bit of that in our lab. Common criteria that can be filtered: source and destination IP address. Where is it coming from? Where is it going? Source and destination ports. What protocol traffic you're trying to use or where you're trying to go. Flag set in the TCP header. Transmissions using UDP or ICMP, ping or trace, that sort of thing. The packet status is the first packet in the new data stream and subsequent packets. Packet status is inbound to outbound from private network and so forth. Again, these can all be used as criteria to permit or deny certain levels or certain types of traffic. We can also, in here, if we think back to our wildcard mask and so forth, the admin could prevent any IP address that does not begin with the network ID from accessing the router servers. Admin could also disable or block certain well-known ports. So I can do a couple parameters here to prevent a specific type of traffic. Ports can be blocked not only on firewalls but also on routers, servers, and other devices. Okay, we did routers already, but we could do a certain blocking of certain ports and so forth on a router. It can also be done on a firewall, and in many cases can also be done on nodes or web servers. So web servers designed to listen to 80 for HTTP. You might want to close the other ports so they may not enter. The only thing I need to worry about is making sure you're not blocking something like 22. If you need administrative access to the server through SSH, I might need to allow that, but I might be specific. The SSH is allowed if it's coming from a certain network or a certain node or a certain host. I can write a very specific rule for that. Optional firewall functions: encryption, user authentication, centralized management, easy rule establishment. What we're going to find out in our firewall, the writing of the rules is pretty easy because there's a GUI interface that I can use for configuring it. Logging, protect from internal LAN addresses identity. Yes, we can protect all the LAN and IP addresses and so forth inside. Monitor packets to existing traffic streams. Content filtering, some can do even a higher level content filtering. You might have a type of firewall that's a stateful or stateless. Stateful is going to inspect each packet and determine if it belongs to an active connection. So is this a legitimate packet coming in or is it not? This is going to be a little bit slower because it's more sophisticated. It's going to say, hey, are you part of an existing conversation? If you are, go ahead. If not, okay. Stateless is just going to look at each packet standalone. What are you? Where are you trying to go? What are you? Where are you trying to go? This will be faster, but it's not as sophisticated. Okay, so sometimes you might see in the description it's a stateful or stateless firewall. That'll give you a clue as to how it's going to function in the network. My router at home acts as a firewall, includes packet filtering options. Yes, our routers at home typically have this built into it. Things like our Cisco ASA or the 40net device, like we're going to use in the lab room, is really able to do more. It's able to do a lot more. It's a dedicated security function or security device designed to be able to do more for our network. We can have software that enables a computer to act as a packet filtering firewall. Things like IP tables, zone alarm, Komodo firewall, even Windows Defender firewall can be used to act like a packet filtering firewall, especially on a host node. The most common cause of firewall failure is misconfiguration, not configuring correctly. And when we write rules for our firewall for the lab this week, I'm going to have you write one that is correct, but it's not in the right order, and we'll see what fault that causes. And then we'll move it around and get it in the correct order, and we'll see it's now functioning correctly. Easy thing to do. Easy thing to do. You have to be strict enough to deny what you need, but loose enough to allow through what you need to allow through. So it takes time. It takes time to tweak it and get it functioning correctly. We'll come back and continue on with some IDS and IPS.